Hi, I'm Brad Henry with Landau Controls and Shelly Automation, and in this video I'm going to show you how to use the Universal Robot to perform a laser scan with an L4000 3D laser displacement camera from Cognex. Let's take a look at the overview video I shot. Okay, so I've got the L4000 connected to the Universal Robot. I've had to 3D print a bracket because a bracket doesn't exist for this. So I just went to their respective manuals and found the relevant screw patterns. So let's see what happens. So that was a good scan. You can see the blue light had gone on, so it worked. So let's see what happened from the robot's point of view. So this is my robot program. Everything is under a move P command. So I'm moving at 50 millimeters per second. This will come in handy later, and I'm following a line feature. Now I set a line feature to help with moving a straight line and orientation. This is used for conveyor belts, but since the robot is a conveyor belt, it works here. Now, first waypoint is not a start, it's a run up to the start, and that's because when the robot starts, I don't have the base secure. There's a little bit of movement in the arms. It has some jitters and some acceleration to get out. So I let it run up to speed and start after that. Now, right after it starts, I set the trigger to on, and it's triggered at high. When I finish, I turn the trigger off, and I have a bit of run out to just let the robot slow down before moving back. I can probably remove this in later iterations. Then I have a pop-up window asking me to scan again. That's so I don't have to restart the program over again and wait for it to start up. So let's talk about wiring and I/O. So the robot is powering the sensor. The robot can source up to 2 amps of power. The sensor needs 1, so I'm able to run it. The input common is connected to ground in the robot, and the trigger is connected to 24 volts of digital output at digital output 4. So when digital output goes high, trigger turns on. When it goes low, it turns off. This arrangement means you are tied to an NPN connection, at least for the input common of at least for the camera, as far as the camera is concerned. The laser enable is always on. That's just to make my life easier. You can turn it on or off the same way using digital outputs. Now the scanner works best when it's oriented properly, and considering on a robot with a lot of flexibility, this is important to do so. So I used a line feature and oriented everything according to that line. So I set my rotation vectors to practically 0, and then oriented my Z or my yaw to move according to the way the scanner is moving. I didn't use free drive because free drive is too loose. I used the TCP orientation and the tool position. That's it for the robot. Let's take a look at the L4000. So this is the image that I got. You can see that worked out pretty good. There are a couple of ripples here, and that's probably from the robot just being a little loose. I probably don't have it fixtured the best, but it's still still good enough to see the paper on top of each other here. So we must be doing something right. Now the biggest changes are in point cloud in the acquisition. I set the trigger to hardware. This allows the robot to trigger the camera. Motion input is set to time because we don't have an encoder. No changes in sensor. The motion speed is set to 50 millimeters per second because that's what the process move is. I'd like to do a target correction, but I don't have a target here to do it, so this has got to work for now. And under point cloud, the requested scan length is the distance between the starting and finishing waypoints. And you can get those by going to the start point, go to edit pose. It'll tell you here under TCP. And under finish as well. So you can do some math to figure out how far the robot has moved, and you enter that here. And set your requested Y resolution appropriately, but the camera does know how far it's moving and how fast it's moving, so you should get an undistorted image back. Everything else is the same. Pattern matching is the same. Yeah, I hope you found this useful.